Hello guys, today I am going to show you what are the difference between delta connection and the star connection and how we will do the proper insulation test in the motor. So now the winding is connected in the delta. I am going to measure the resistance between the windings which are connected in the delta. I will clearly explain how delta and the stars are connected in the end of the video. You can watch full video so you will get the knowledge. So see, now I am measuring between the windings which was connected in the delta. I am getting the resistance of around 2.6 2.7 ohms. I will measure for all the windings, all three windings. I will get around 2.7 2.6 ohms. Next, I disconnected the everything. Now we are going to measure resistance between each winding, like U1 and U2 terminal, V1 and V2 terminal, W1 and W2 terminal. So we can came to know what was the resistance of each winding. Let's check. So I put it in the resistance mode of in the multimeter. Now I am measuring the wide resistance between U1 and U2. I am getting around 4 ohms. So I will measure other two windings also. I am getting the same resistance, U1 and U2, 4 ohms, and W1 and W2 I am going to get 4 ohms. After this, I am going to measure the resistance in the star connection. Now I connected the motor in star connection. So if I measure the resistance between U1 and V1 and V1 and W1 and W1 and U1, I am going to get the combination of resistance because we connected the connection in the star. At the end, you can came to know how star connections are connected. Like star connection, we can say it is a series connection. Let's check the resistance. And one more thing, what is main difference between star and delta is, in star you will get a more speed will be good, in the delta you will get a more torque, so you can take a more load in the delta connection. See, I am measuring the resistance between U1 and V1. I am getting around 8 ohms. So now you came to know the star connection is called seriously connected. So V1 and W1 also giving 8 ohms, 7.9 to 8 ohms. So with the more torque in the delta, that's why it is getting high current to take that much load. Actually, current always depend upon the load. So once you are giving more load, the current will be more. That's why if the load is more, they always use it to prefer the motors to connect in the delta connection. Now we will measure the insulation resistance between body of the motor to the windings. So we came to know that motor windings are not shorted. So I am measuring the insulation resistance between body and the X1. So it was around 5 mega ohms. It was in the good condition insulation in the, so we no need to put any extra additional varnish. So we can assemble it as it is. So all windings are giving around 5.5 mega ohms. Now we will measure the resistance between the windings. So we will came to know that the windings are not shorted between them. So now I am going to measure the insulation resistance between. I connected the negative terminal of the Megger to the one of the windings and I measured between other two windings. So I came to know these windings are not shorted. So each windings are giving almost around 5.5 mega ohm. This was a good value, so we no need to do any extra additional varnish. We we are doing motor overhauling. If there is resistance falls below 1 to almost, if it falls below 4, then do little bit varnish and keep it dry for a day and assemble in the next day. Otherwise you can do, if it is a 5.5 mega ohm, you can just do change of the bearings and you can assemble it back. So this is the each winding in the motor U1, U2, UV1, V2, W1, W2. So each winding resistance we are getting as 4 ohms. Okay, so we are getting 4 ohms. So once we connected the motor in the series connection, while we measuring the resistance between U1 and the V1, so we are getting 8 ohms. That's why series connection are called. So when the star connection is also called a series connection. So then we measure V1, W1, we get 8 ohms. Then W1 and U1 we get 8 ohms. See, if in the delta connection you will get a normal resistance. See, when you the motor is connected in delta, you can find out U2 is connected to V1, V2 is connected to W2, and W1 and W2 is connected to U1. Okay, so once we measure the resistance, so we will usually get 4 ohms between U1 and the V1 because it is connected in the delta, and V1 and W1 we will get only 4 ohms. So W1 and U1 we will get only 4 ohms. So this is the insulation resistance check. See, these are the windings, so we need to check like this. From winding to body, we will correct the earth of the insulation meter here, and we will test the Megger test. We will do it here. For each winding we need to do it like this. Between the windings we will take the earth cable of the Megger and we will put any one of the places of the winding, and we will check in this winding. So by this we can find out the windings will not short. So while measuring the resistance between this winding and the earth, we can find out there is no short in the body. Thank you. Do well.